The year is 2077. Humanity decided it was time for something truly spectacular, not just another Mars rover or a small research outpost. No, this time the plan was big, really big. They were going to build a skyscraper on Mars, not just any skyscraper, but the tallest structure ever conceived by humankind, right near the base of Olympus Mons. It would be a symbol of human ambition, a beacon of our reach into the cosmos. The project was codenamed Olympus Tower, and it captured the imagination of every single person back on Earth. It was a bold statement, a challenge to the universe itself, showing we were here to stay and explore. Planning for Olympus Tower took decades of meticulous work. Scientists, engineers, architects, and even dreamers collaborated across nations. They had to invent entirely new materials, lightweight yet incredibly strong, capable of withstanding the harsh Martian environment. They needed construction techniques that could work in low gravity and with minimal atmospheric pressure. The logistics alone were staggering. How to transport millions of tons of equipment and prefabricated components across tens of millions of miles of empty space. Every calculation had to be perfect, every contingency planned for, because on Mars there was no room for error. No quick supply run if something went wrong. The primary goal of Olympus Tower wasn't just to be tall. It was designed to be a major research hub, a self-sustaining habitat, and a staging point for further exploration of Mars and beyond. It would house laboratories for geology, biology, and atmospheric science. It would have advanced life support systems, capable of recycling air and water with near-perfect efficiency. Residential modules would provide comfortable living quarters for hundreds of scientists and support staff. And at its very top, an observatory with unparalleled views of the Martian landscape and the star-dusted heavens, offering insights we could only dream of from Earth. Funding such a colossal undertaking required unprecedented global cooperation. Old rivalries were set aside, and nations pooled their resources and expertise. Children in schools followed the project's progress with wide-eyed wonder, inspired by the sheer audacity of it all. This wasn't just a scientific mission, it was a human endeavor, a testament to what we could achieve when united by a common, ambitious goal. The dream of Olympus Tower fueled innovation in countless fields, from robotics to materials science, pushing the boundaries of what was thought possible. Earth was betting big on Mars, and Olympus Tower was its most ambitious hand yet. The launch day for Ares 7, the primary construction vessel, was a global event. Billions watched as the colossal ship, assembled in Earth's orbit, prepared for its long voyage. This wasn't just a single rocket, it was a fleet of interconnected modules carrying the initial construction crews, advanced robotic builders, and the foundational elements of Olympus Tower. Commander Eva Rostova, a veteran astronaut with nerves of Martian steel, gave the final go-ahead. The powerful plasma engines ignited, a brilliant blue against the blackness of space, and Ares 7 began its slow, majestic departure from Earth's embrace, heading towards the distant red dot in the sky. The journey to Mars took 7 long months. For the crew, it was a period of constant checks, system diagnostics, and training simulations. They lived in rotating sections of the ship to maintain some semblance of gravity, staving off the worst effects of muscle atrophy and bone density loss. They practiced emergency procedures for every conceivable disaster: micrometeoroid impacts, solar flare radiation bursts, critical system failures. Space is a harsh and unforgiving place, and the Ares 7 was a tiny bubble of life in an immense void. The crew knew the risks, but the promise of building Olympus Tower, of making history, kept their spirits high and their focus sharp. As Ares 7 approached Mars, the planet loomed larger and larger, a captivating sphere of red and ochre. The intricate details of its canyons, craters, and ancient riverbeds became visible, a landscape both alien and strangely familiar from countless telescopic images. The crew performed the crucial Mars orbital insertion burn, a nerve-wracking maneuver that had to be executed with pinpoint precision. A mistake here could mean either skipping off into deep space or burning up in the thin Martian atmosphere. But the engines fired perfectly, and Ares 7 settled into a stable orbit around the red planet, ready to begin the next phase of its historic mission. From orbit, the chosen construction site near Olympus Mons was surveyed one last time. It was a relatively flat plain, selected for its geological stability and access to potential subsurface ice deposits. The initial cargo landers, packed with robotic bulldozers, power generators, and habitat modules were prepped for descent. The first humans to set foot on Mars in over a decade were about to make their mark, not just with footprints, but with the foundations of the tallest structure in the solar system. The air in the command module was thick with anticipation and a touch of understandable trepidation. The real work was about to begin. Landing the first construction modules was a masterclass in automated precision. Huge retro rockets fired, kicking up clouds of fine red dust as the landers settled gently onto the Martian surface. Within hours, robotic systems unfolded, solar panels tracked the distant sun, and the first habitat, a sturdy, inflatable structure, was pressurized. Commander Rostova and her lead engineer, Kenji Tanaka, were the first to step out onto the Martian plain. The air was thin, cold, and the sky was a pale pink. The silence was profound, broken only by the hum of their suit systems and the whirring of the nearby robots. This was their new home and their new worksite. The challenges of building on Mars became immediately apparent. The fine Martian dust, or regolith, was a menace. It was incredibly fine, almost like talcum powder, and it got into everything. Suit joints, airlocks, mechanical components. Special magnetic seals and cleaning protocols had to be rigorously followed. Then there was the gravity, only about 38% of Earth's. While it made lifting heavy objects easier, it also meant that traditional construction techniques relying on weight for stability had to be rethought. Structures needed to be anchored deeply into the Martian crust to prevent them from toppling over in the strong winds that could whip across the plains. Radiation was another constant concern. Mars lacks a global magnetic field and has a much thinner atmosphere than Earth, offering little protection from solar and cosmic radiation. The habitat modules were heavily shielded, and the tower itself would incorporate radiation-blocking layers into its outer shell. Workers had to limit their time outside, even in their advanced suits, and rely heavily on teleoperated robots for much of the external work. Daily radiation exposure was carefully monitored, and shifts were planned around periods of lower solar activity. It was a constant battle against an invisible enemy, a reminder of how alien this new world truly was. Despite these hurdles, progress was steady. The robots, guided by human supervisors, began excavating the foundations for Olympus Tower. They used powerful lasers to sinter the Martian regolith into a hard, ceramic-like material, creating Martian concrete on site. This reduced the need to transport vast quantities of building materials from Earth. The first sections of the tower's core, prefabricated on RE-7 and carefully lowered to the surface, were meticulously aligned and welded into place. Slowly, painstakingly, the base of the colossal structure began to take shape against the backdrop of the towering Olympus Mons volcano. Human determination was literally breaking new ground. As Olympus Tower began to climb, new engineering challenges emerged daily. The low atmospheric pressure meant that wind forces, while generated by less dense air, could still be significant on such a tall, slender structure, especially during Mars's infamous dust storms. Advanced aerodynamic modeling and active dampening systems were incorporated into the tower's design. These systems could subtly shift the tower's mass or adjust its external surface to counteract wind loads, ensuring its stability. It was like giving the skyscraper its own set of reflexes, constantly adjusting to the Martian weather with quiet efficiency. Temperature fluctuations on Mars are extreme, ranging from relatively mild at the equator during the day to incredibly cold at night, often dropping below -100 degrees Celsius. The materials used in the tower's construction had to withstand these thermal stresses without cracking or warping. Special composite alloys with low thermal expansion coefficients were developed specifically for this project. The tower's outer skin was also designed with multiple insulating layers, helping to maintain a stable internal temperature for the occupants and sensitive equipment housed within its metallic shell. It was a constant fight against the planet's relentless attempts to freeze everything solid. One of the biggest headaches was simply getting materials up to the ever-increasing height. Traditional cranes were difficult to operate effectively in the low gravity and thin air. The solution was a combination of internal lifts running up the core of the tower and external, magnetically levitating construction platforms that could climb the tower's sides. These platforms were operated by advanced AI, coordinating their movements with incredible precision to deliver components and robotic workers exactly where they were needed. It was a ballet of high-tech machinery, a dance of construction reaching towards the crimson sky, slow but undeniably upward. The human element, while crucial, also presented its own set of challenges. Living and working in such a confined, hazardous environment for extended periods took a psychological toll. The construction crews rotated back to the Ares 7 orbital station for rest and recuperation. Regular communication with Earth, despite the time delay, was vital for morale. Virtual reality suites allowed them to visit familiar earthly landscapes, a brief escape from the red dust and confined spaces. Every completed section of the tower was a victory, a testament to their resilience and the power of the human spirit to adapt and overcome even the most daunting obstacles. Section 5. Unscheduled arrivals. The Xylar delegation appears. One sol, roughly halfway through the tower's primary construction phase, something entirely unexpected happened. The long-range sensor array, primarily designed to detect incoming meteoroids or unusual solar activity, picked up an object decelerating into Mars orbit. It wasn't human, it wasn't a rock. It was sleek and possibly smooth and moving with a controlled grace that defied all known human propulsion technology. Panic was a mild word for the initial reaction at Mars Command and back on Earth. First contact protocols, long-gathering dust in classified files, were suddenly front and center. This was definitely not in the project plan. The alien vessel, a shimmering silver teardrop shape, made no hostile moves. It simply parked itself in a high Martian orbit, observing. After a few tense hours of human deliberation and frantic attempts to establish communication using every conceivable method from radio waves to mathematical sequences, the aliens sent a message. It wasn't in English or Russian or Mandarin. It was a complex series of tonal patterns and geometric light displays, which Earth's best xenolinguists and AI programs began to decipher with feverish intensity. The message, once translated, was surprisingly mundane. We detect unlicensed megastructure construction. It turned out the local sector of the galaxy, unbeknownst to humanity, had a sort of interstellar building code and a very diligent, if somewhat bureaucratic, inspection agency known as the Xylar Concorde. Apparently, building a kilometer-high tower on a previously uninhabited, by advanced life anyway, planet triggered some kind of cosmic planning permission alert. The Xylar, a species known for their meticulousness and passion for structural integrity across various planetary conditions, were dispatching an inspection team. Humanity had just gone from being pioneering explorers to potentially unlicensed cosmic cowboys in the eyes of their new galactic neighbors. Commander Rostova was tasked with handling this unprecedented situation. While engineers worried about whether Martian concrete met Xylar standards, diplomats on Earth scrambled to understand the implications. The Xylar message indicated their shuttle would arrive at the construction site in 3 Martian sols. They requested a competent project manager to be available. There was a new kind of pressure now, not just from the Martian environment, but from the unknown expectations of their first alien visitors. The half-finished Olympus Tower suddenly felt like it was under a very different kind of scrutiny, one that spanned galaxies. Section 6. Diplomatic dithering, first contact and cosmic comedy. The Xylar inspection shuttle was a thing of beauty and terror. It detached from the mothership and descended with an eerie silence, settling gently a few hundred meters from the Olympus Tower base. It looked like a polished riverstone, impossibly smooth, with no visible seams or propulsion systems. A ramp shimmered into existence, and 2 figures emerged. They were tall, slender, with skin that seemed to shift in color, reflecting the reddish hues of the Martian landscape. They wore simple, elegant garments that flowed around them. Each had 4 arms and large, dark eyes that took in everything with unnerving calmness. They were unmistakably alien. Commander Rostova, flanked by Kenji Tanaka and a hastily assembled welcoming committee in their bulky EVA suits, approached cautiously. "Welcome to Mars, representatives of the Xylar Concorde," Ava said. Her voice broadcast over her suit radio, hoping the universal translator earpiece the Xylar had somehow provided via a small data packet sent ahead was working. One of the Xylar, slightly taller, raised a three-fingered hand. A synthesized, perfectly accented English voice emanated from a small device on its chest. "Greetings, I am Inspector Zorp. This is Sub-Inspector Fleeg. We are here to assess compliance of Project Olympus Tower." Zorp's tone was polite, but utterly devoid of warmth. The initial tour around the base facilities was a study in awkwardness. Zorp and Fleeg moved with an unnerving grace, their heads swiveling to observe minute details. Fleeg carried a device that hummed and clicked, occasionally emitting soft beeps. When Kenji tried to explain the innovative use of Martian regolith for concrete, Zorp simply stared at a support beam for a full minute, then made a small notation on a floating holographic pad. "Primitive, yet surprisingly robust," Zorp commented, which Kenji wasn't sure was a compliment or an insult. The humor was unintentional, mostly stemming from the sheer absurdity of the situation. The aliens seemed particularly fascinated by the concept of duct tape, which one of the maintenance crew had used for a temporary fix on a piece of non-critical equipment. Fleeg prodded it gently with a slender finger, its skin briefly flashing a puzzled shade of orange. "This adhesive bonding strip," Fleeg chirped, its translator rendering the term with comical precision. "Its tensile strength appears variable. Is this a primary load-bearing component?" Ava had to quickly explain it was just a temporary measure, feeling a flush of embarrassment that even Martians probably didn't experience. The Xylar were clearly operating on a different technological and perhaps aesthetic wavelength. Section 7, the towering tour showcasing human ingenuity under pressure. The real test began with the inspection of Olympus Tower itself. Zorp and Fleeg, declining the offer of human-sized transport, simply floated upwards alongside the external construction lift, their personal anti-gravity technology making the ascent effortless. Eva and Kenji followed in the lift, feeling decidedly clunky. As they rose, the vastness of the Martian landscape unfolded around them. Even the stoic Xylar paused for a moment, their large eyes scanning the horizon where the curve of Mars was visible. "The atmospheric density here is suboptimal for unprotected carbon-based bipedal life forms," Fleeg observed factually, as if reading from a checklist. Inside the partially completed sections, Zorp and Fleeg examined everything. They ran their strange devices over welds, structural supports, and life support conduits. Zorp seemed particularly interested in the radiation shielding, tapping it and listening to the echoes with an intensity that made Kenji sweat despite the cool air in his suit. "Your methods for mitigating high-energy particle bombardment are creative," Zorp stated, its head tilting. "We typically employ localized dimensional distortion fields, but this layered physical barrier approach has a certain rustic charm, assuming it actually meets the minimum attenuation requirements for Class G planets." The humans showcased their robotic construction techniques, the AI-driven welders and assemblers working tirelessly. Fleeg seemed to enjoy watching the robots, its skin shimmering with faint blue and green patterns. "Autonomous construction units. Acceptable efficiency for a species at your developmental stage," Fleeg commented, its voice still flat but somehow less critical. Eva pointed out the internal recycling systems, the closed-loop water purification, and the experimental hydroponic farms designed to provide fresh food. These were areas where human ingenuity had truly shone, born from the necessity of surviving in a hostile environment. One moment of near disaster, or perhaps cosmic comedy, occurred when a small maintenance bot, affectionately nicknamed Clanky, malfunctioned and bumped into Inspector Zorp's leg. Zorp didn't flinch, but its skin flashed a startling shade of crimson for a split second. Eva's heart leapt into her throat, but Zorp merely looked down at Clanky, which was now beeping apologetically, and said, "Unit requires recalibration of its proximal awareness sensors." Kenji quickly had Clanky scurried away, muttering apologies. The tension was thick enough to be cut with a laser torch, but the tour continued, level by painstaking level. Section 8, Alien Eyes, Human Pride. The Xylar verdict looms. As the tour reached the upper, still under construction levels, the Xylar inspectors focused on the unique challenges humanity had overcome. They examined the systems designed to compensate for the low gravity, the deep anchoring techniques, and the flexible joints built into the tower to withstand Marsquakes. Kenji explained the countless simulations, the failures in early prototypes, and the breakthroughs that finally led to the current design. He spoke with a quiet pride about the human teams who had poured their lives into solving these monumental problems, thousands of minds working together across vast distances of space. Zorp and Fleeg listened intently, their expressions unreadable, though Fleeg's skin occasionally pulsed with soft, inquisitive yellow light when Kenji described a particularly ingenious solution. They were shown the plans for the top-level observatory, designed to offer unparalleled views of the cosmos. Eva emphasized that the tower was not just a feat of engineering, but a testament to humanity's desire to learn, to explore, and to understand its place in the universe. She hoped this resonated with the Xelar, who were clearly an advanced, spacefaring civilization themselves. The silence from the inspectors was unnerving. Every human on Mars and many on Earth awaited their judgment. After what felt like an eternity of silent observation and data gathering with their humming devices, Inspector Zorp turned to Eva. "Commander Rostova," it began, its synthesized voice echoing slightly in the unfinished chamber, "your species displays a remarkable tenacity. You have chosen a challenging environment for such an ambitious undertaking." Zorp paused, and Eva held her breath. "The materials are unconventional by galactic standards, and some of your methodologies are, shall we say, spirited rather than optimal. However," Zorp continued, and Eva's heart skipped a beat, "the fundamental structural integrity appears adequate for its intended purpose and local planetary conditions." Fleeg chimed in, its skin now a calm, steady blue. "The redundancy systems are surprisingly thorough given the primary system's artisanal nature, and the dedication to crew safety, despite the inherent risks of the project, is commendable." It was faint praise perhaps by Xylar standards, but to the humans it sounded like a symphony. The aliens weren't just looking at blueprints and material stress tolerances, they were seeing the human effort, the sheer bloody-minded determination that had brought them this far. They saw the passion behind the project, the drive that pushed a young species to reach for their stars, quite literally. Section 9, A Red Planet Triumph, Universal Acclaim and Future Horizons. Inspector Zorp made a final notation on its holographic pad. The Xylar Concord finds Project Olympus Tower to be provisionally compliant with Interstellar Building Code, subsection Alpha 7, pertaining to emergent species megastructures on Class G non-native worlds. Minor recommendations for enhanced long-term particle shielding efficiency and duct tape replacement will be forwarded. Eva almost sagged with relief. Provisional compliance, it was more than they could have hoped for. "We will require periodic updates, of course," Zorp added, almost as an afterthought, "and perhaps a sample of this duct tape for further analysis." Fascinating. The departure of the Xylar was as smooth and silent as their arrival. Their shuttle lifted off, rejoining the shimmering mothership, which then vanished into the blackness of space with a casual disregard for known physics. On Mars and back on Earth, a collective sigh of relief was followed by jubilant celebrations. Humanity hadn't just built a tower, they'd passed their first galactic inspection. The news of the successful, if slightly bewildering, alien encounter added a whole new dimension to the Olympus Tower project. It was no longer just a human achievement, but a structure that had, in its own way, been acknowledged by the wider galactic community. Construction resumed with renewed vigor and a slightly surreal sense of humor. Remember, Xylar-approved welds only became a common joke among the crew. The minor recommendations from the inspectors were implemented, and yes, a carefully packaged roll of industrial-strength duct tape was prepared for the next Xylar check-in, if it ever came. The tower continued to grow, section by section, a gleaming spire against the red Martian sky, a symbol not only of human ambition, but now also of unexpected interstellar diplomacy. The universe, it turned out, was a much stranger and more interesting place than they had ever imagined. Years later, when Olympus Tower was finally completed, it stood as a beacon of research, exploration, and interspecies understanding of a sort. It was a testament to human creativity, resilience, and our ability to face the unknown, whether it was the harshness of a new planet or the surprise visit of alien building inspectors. The Xylar never did explain why they cared so much about building codes across the galaxy, but their visit had changed humanity's perspective forever. We weren't alone, and apparently even in the vastness of space you still needed to get the right permits. And that, everyone agreed, was strangely reassuring.